Main rotor head. The main rotor head is fully articulated and is splined to and supported by the main drive shaft of the main gearbox. It supports 6 rotor blades. Constructed of aluminum and steel, it is approximately 7 feet in diameter and weighs approximately 2,000 pounds. The head is lubricated with grease through approximately 150 grease fittings. Main rotor head components. Hub. Made of steel, the hub contains splines that mate to the output shaft of the main transmission. Upper and lower plate assemblies. Made of aluminum, they form the main structure of the head assembly. Hinge assemblies. 6 hinge assemblies are attached between the upper and lower plates. These consist of vertical and horizontal hinges. Vertical hinge assembly allows the blade to lead and lag. It is limited by a dampener to 15 degrees lead and 3 degrees lag. Horizontal hinge pin attaches the sleeve and spindle to the vertical hinge and has attachment point for the outboard end of the dampener. It allows the blade to flap up 30 degrees and down 5 degrees. Dampeners. These are installed on brackets between the 2 plate assemblies and attached to the horizontal hinge of each blade. The dampers slow the back and forth hunting of the blade during rotation and absorb loads caused by changes in main rotor RPM or blade pitch. They contain the lead and lag stops. They are self-bleeding and receive hydraulic fluid from the reservoir on top of the center hub. The dampener timing is not adjustable. Sleeve and spindle assembly. Made of steel, they allow the blades to change pitch, feather. They are secured to the vertical hinge by the horizontal hinge pin. The sleeve is mounted over the spindle and separated by 8 stack bearings. The pitch horn is part of the sleeve assembly. The non-adjustable control rod, also called the non-adjustable pitch change link. It transmits control inputs from the rotating swash plate to the K-bar. The K-bar, or torque tube assembly, called a K-bar because it is shaped like a K. It transmits control inputs from the non-adjustable pitch change link to the adjustable pitch change link. The adjustable control rod, or adjustable pitch change link, it transmits control inputs from the K-bar to the pitch horn on the sleeve. It is also used for making tracking and rigging adjustments. Restrainers. Droop restrainers prevents the blades from drooping below 0 degrees when the rotor speed is slow. The droop stops are spring-loaded in and require centrifugal force to pull them out. The droop should be out by 75% NR on run-up and in by 40 degrees NR on shutdown. Anti-flap restrainers are mounted on top of the vertical hinge assembly. They are spring-loaded in and require centrifugal force to pull them out. They restrict flapping of the blades when the head is static or slow RPM. They come out at approximately 26 degrees NR. Swash plate assembly. It is made up of 2 swash plates, the rotating and the non-rotating swash plates. The assembly transfers control inputs from the primary servos to the rotating components of the head. A spherical bearing allows the swash plate to be tilted in any direction and at the same time to be raised and lowered on its vertical axis. When the flight controls move the primary servo cylinders, the stationary swash plate moves the rotating swash plate. From the rotating swash plate, the control movements are transmitted by the non-adjustable control rods, the torque tubes, and the adjustable control rods to the horns of the sleeve and the spindle assemblies to change blade angles. Rotating swash plate made of steel, it provides the mounting for the 6 non-adjustable control rods. It is separated from the stationary swash plate by 1 set of ball bearings. It is driven by 2 rotating scissors attached to the lower plate. Stationary swash plate. Made of steel, it is under rotating swash plate and provides mounting for 3 flight control servos. It is kept from rotating by 1 stationary scissors. Main rotor blades. Approximately 32 feet and 8 inches long with a 23.65-inch chord. The blades are made of a hollow extruded aluminum spar, sealed with stainless steel abrasion strip on the leading edge. There are 27 aluminum skin reinforced rib-style pockets. There is an aluminum tip cap and an aluminum root cap. Each blade is statically balanced with tolerances that permit individual replacement of the blades. Each blade has a BIM, a blade inspection method indicator, near the root, as well as Schrader-type servicing valve and a steel cuff that attaches the blade to the main rotor head. The blades weigh approximately 355 pounds each. BIM indicator. A BIM indicator is installed in the back wall of each glass cover through which a color can be seen to determine blade serviceability. The indicator compensates for changes in temperature and compares a reference pressure, approximately 10 psi, built into the indicator with the spark pressure. When the pressure in the blade is within required limits, the slots in the glass cover show yellow or white, indicating the blade is serviceable. If the pressure in the spar drops below the minimum permissible service limits, the indicator shows red or black, denoting an unsafe condition. This unsafe indication can be caused by a crack or simply a leaky seal or valve. In addition to the functional and visual checks of the BIMs prior to the first flight of the day, EAC service bulletins for both the E and the F models state that each BIM indicator be inspected every 3 hours time in service from the last check for aircraft engaged in 7 or more external lifts per hour. Every 5 hours time in service from the last check for aircraft engaged in either less than or equal to 7 external lifts per hour, or operating without external cargo. Tail rotor head. The main rotor head is semi-rigid, self-lubricating, four-bladed design. It is mounted on and driven by the tail gearbox output shaft. The pitch is controlled through tail gearbox pitch control shaft, pitch beams, and pitch links. Tail rotor head components. The hub. Made out of titanium, it is splined to the gearbox shaft. Sleeve and spindle assembly allows the blades to feather and flap. Flap restrainers. Plunger type. They are centered in the sleeve assembly and are spring-loaded out into the hub to prevent blade flapping at low RPM or when static. The plungers start to retract at 35 degrees NR and are fully retracted by 50 to 60% NR. With the plungers fully retracted, the blades are allowed to flap plus or minus 10 degrees. Pitch beam. The pitch beam is splined to the pitch control shaft that travels through the gearbox from the tail rotor servo. It transfers servo inputs to the pitch change links. Pitch change links. They are attached to the pitch beam on one end and the pitch horn on the sleeve on the other. They transmit control inputs to the pitch horn. The pitch links are adjustable for blade tracking. Lubrication system. In the center of the hub is a circular reservoir commonly called the donut. It has a yellow outer line and a red inner line. The top yellow line is maximum level for oil in the reservoir. The bottom of the red line is the minimum oil level allowed. Tail rotor blades. They utilize a similar type of construction as the main rotor blades. Each tail rotor blade consists of an aluminum pocket, aluminum ribs, and hollow aluminum spar. A titanium cuff and a tin cap and a fairing are attached to the blade. There is no BIM system on the tail rotor blades.